Okay, in this video, I'm just gonna continue where I left off on that same worksheet. This is Simplifying Rational Expressions Worksheet 3.1. It can be found on the Canvas page. And this is just like we were doing before. We just had one fraction, but here we have two. So your first move here is to rewrite this, or at least to think about it in your mind as just one big fraction. Because all we're doing when we multiply fractions is you multiply top by top and bottom by bottom. And as long as I'm switching it into one big fraction, I'm going to factor as I go. So for example, I could think of 24 as 4 times 6 times x cubed, and 15 as 3 times 5 times y squared. On the bottom, I'm going to have a 5 times a 5, a y to the 5th, and 8 is 4 times 2, x squared. Notice I'm not being careful to actually break them into prime factorizations. I'm just looking at the numbers and trying to break them into factors where I can see some common factors. So when I write it like that, and I can see some things that will cancel. For example, that 4 and that 4 will cancel. That 5 and that 5 will cancel. Actually, I should have broke the 6 into 2 and 3, shouldn't I have? So if I write this as a 2 and a 3, then I can see that 2 cancel with that 2. And then, once I do that, I'm able to go ahead and again, you don't have to do that, it helps. I'm just doing it so you can see the factors easier. So what's left on top as far as numbers go is 3 times 3, which is 9. And what's left on the bottom as far as numbers go is just a 5. Then I look at the variables, and it looks like I have an x cubed on top, x squared on the bottom. That means 2 of the x's on the bottom will cancel out 2 of the x's on the top, leaving just an x. And finally, I have y squared on top, y to the 5th. So it'd be 3 y's, factors of y left over on the bottom. And that would be my answer. So the same thing here. I'm not going to write it out like that, but I'm going to think like that. So picture me thinking like that, but I'm going to just look at this saying, oh, I can take out a 3 from there, so that'd leave 4, and take out a 3 from there. I can take out a 5 from there, and I can take out a 5 from there. And so then it looks like I got 4 times 8 on top, which would be 32. And I have 3 times 5 on the bottom, which would be 15. And I have x cubed on top, x squared on the bottom. That would leave just an x on top. Okay, now, once we get over to these, it really becomes important to factor them first. So, for example, on this one, I would rewrite it as one fraction, but it would be 6 times 5 times x minus 5. And on the bottom, I'm going to have x looks like 5 and 4, minus and minus, times 15. And in fact, I could rewrite 15 if I wanted to see it easier. 3 times 5, couldn't I? So then I notice, if I grab my handy-dandy red canceller pen, I notice that the x minus 5s will cancel, and the 5 will cancel. And what am I left with when all the canceling is done? It looks like just a 6 on top. And on the bottom, I have a 3 times x minus 4. So I'm going to go ahead and multiply that through, and I would get 3x minus 12. Oh, wait a minute. Back up a second. Nope. That 3 and that 6 will cancel, won't they? So I can cancel this out. 2 times 3. And the 3's will cancel. So I'm actually just going to have a 2 on top. And only an x minus 4 on the bottom. Oh, that was a close one. Okay, so let's do a couple more of these. Again, down the bottom, I'm going to factor first. So I'm going to have one fraction because I'm just multiplying top by top, bottom by bottom. So I'm going to have a 6 times x minus 3 times x cubed. And here I'm going to have a 4 times x squared times 2 times x minus 3. And so then we can see some things canceling here. Maybe I'll cross out that 6 and write a 2 times 3. That'll be helpful. So then, again, grab my red canceling pin. And x minus 3's will cancel out, because that's a factor at the top. The 2 will cancel out. And x squared will cancel with some of those, leaving just an x. So then my final answer, I'll grab my final answer pin, would be on top, just 3 times x. On the bottom, it looks like just a 4, doesn't it? Okay, so here's one that the top is already factored for us, so it'd just be x plus 3 times x plus 2. Notice I throw parentheses around it because I want to just multiply it as all on the same fraction. And I can't just put a dot in between them because I'm multiplying this whole thing by that whole thing. Then down the bottom I have a 4, and I got an x and an x, and that would be 3 and 1. So then I'm looking for things to cancel. I can see the x plus 3's. So then I'll be left with x plus 2 on top. And on the bottom, I'll be left with a 4 times x plus 1, which would be 4x plus 4. Okay, so again, notice I'm factoring them so I can see things that cancel. Once I've canceled everything can cancel, then I'm simplifying again. Because remember, factoring is the opposite direction of simplifying. Okay? And let me do these 2 more. Actually, I'm going to jump down as long as we're on, and then I'll come back in and fill in the missing ones, because number 28 is division. So when I'm dividing by a fraction, remember, division is the multiplying by the reciprocal. So I would do the same idea, but on top, I'm going to have an x minus 5 and a 6 on the bottom. And so when I flip this over and multiply, that means I'd have a 12 on top, and I'd have a 2 times x minus 5 on the bottom, because this thing factors into 2 times x minus 5. But the division caused me to flip the thing I'm dividing by over. So in this case, looks like I have 2 times 6 right there on the bottom, which we all know is 12, so I can cancel both of these out with that. And actually the x minus 5 with x minus 5, and look at that. What are we left with? Everything cancels out. And so some of you may be tempted to say there's nothing left, but remember, when you cancel, you're left with a 1, because 12 divided by 12 is 1. That's why we can cancel it. So that was kind of fun. The whole thing disappeared. Let me do another division one right down. Here's a humdinger. Let's do this one. So I'm going to factor everything while I move it. Hopefully that's okay. So that'll be m and m, a 4 and a 2, and that'd be a negative 4 and a positive 2. And on the bottom, I'm going to 8 times m plus 3. And then, again, this is going to, the 2m minus 8 is going to go on the bottom, but I'm going to write it as 2 times m minus 4. On the top, I'm going to have this m squared plus 7m plus 12 factored. So I'll put those 2 there, and that'd be m and m. That'd be 3 and 4, and plus and plus. Okay? So then I look for things to cancel. I'm going to go ahead and bring out my red pen for this, because there's a fair number of things, I think. So let's see, an m plus 3 and an m plus 3 will cancel. An m minus 4 and an m minus 4 will cancel. And I think that's it. So what am I left with? I've got an m plus 2 times m plus 4. On the bottom, I just have 16. And that's in factored form, so let's put it back in simplest form. So if we multiply that through, we get m squared plus 6m plus 8 all over 16. Wow, that's fun. Gee willikers, golly gee. Okay, we're coming up on the plus or minus here. I think I will pause the video and finish these other ones I haven't finished yet. Okay, so I did some videos, or did some problems offline, so just so you can see them. Like there's 29, and I think I did 30, and 32, and 33. So you can check those, so you can check yourself so you don't wreck yourself. And then we're going to move on to adding and subtracting rational expressions. So the main thing, if you remember our little list over here, main thing you have to remember to add and subtract, you must have a common denominator. So that's good to keep in mind. And notice here these two already have a common denominator, 15x. In other words, both fractions have the same denominator. And so when they do, you can just add them. We add the tops and the bottoms stay the same. So these also, that also goes to subtraction. So that'd be, and these are like terms. You got 5x over 7 and 2x over 7. So that would be 3x over 7. Okay. And here's a couple more like terms. So these are pretty straightforward. Just 4x plus 7 over 2x plus 3. And of course, this one's going to be 2 plus x over 5x plus 9. Now, when you do these, you should check to see if you can reduce them at all, simplify them. But in this case, I can't factor anything out of that or out of that, and they're not the same. So we cannot factor them. We cannot factor cannot cancel the 2 with the 4 because 2 and 4 are not factors of the top and bottom. Okay, same thing down here. All right, moving along. Here's a couple more, and this one's a little bit more complicated because I have an x minus 1 plus 2x plus 9 on top and a 3x plus 4 on the bottom. So I'm just adding all that stuff on top. And well, I kind of wrote kind of big there. Didn't leave a lot of room for myself. But I've got to combine like terms on top, don't I? So I have to write smaller here. So x and 2x, that'd be 3x. And negative 1 and 9, that'd be positive 8. And then I'd have a 3x plus 4 on the bottom. Okay, so you can see the way that works. It's pretty easy if they're common denominator. If they already have a common denominator. Here we go. Notice when we subtract here, this is an important one. Since there's a subtraction there, that means I'm really subtracting both of these terms. So when we go to write it as a one fraction, this would be 7x plus 4 minus 3x plus 2, because that minus applies to that minus. So you're distributing the minus sign through. And of course, in the bottom, I'm just going to have x squared plus 3x plus 2. So then when I combine these things together, 7x minus 3x, that'd be 4x. And 4 plus 2 would be 6. I'll rewrite that, sorry. And on the bottom, I still just have x squared plus 3x plus 2. Now I look at that though, I'm worried that I might be able to cancel some out of that. So I'm going to go ahead and factor everything because these are not factored. So if I factor this, that would be 2 times 2x plus 3. And on the bottom, I'd factor that into x and x, 2 and 1, and plus and plus. And when I do that, I'm rest assured that I do not have anything on top and bottom that I cancel. So I can go ahead and erase that off and say this actually was my final answer. Okay. So now we get to number 40. This is where it gets interesting. Notice we do not have common denominator. They're different. And so when I'm looking for a common denominator, I need to include in my fraction x plus 2 and x minus 5. So that's what my new fractions are going to look like. I have to have something that both x plus 2 and x minus 5 will divide into. Okay? And when you're, the cool thing about, as I said in the other video, when you're changing to a common denominator, it's just like reducing, only in reverse order. So just like when you have the same thing on top and bottom, you can cancel. Well, to change this fraction, I can multiply top and bottom by the same thing. So what I'm looking for is, what is this first fraction missing? It's missing an x minus 5. So that means that on top I'm going to have a 7 times x minus 5. Same thing over here. What is this fraction missing? It's missing x plus 2. So that means I'm going to have a 4 times x plus 2. Because the way I got this fraction from that fraction is I multiplied top and bottom of this fraction by x plus 2. Okay, so once I do that, I'm going to multiply it out and subtract. So that would be 7x minus 35 minus 4x minus 8. So that would be my top, and the bottom is just going to be x plus 2 times x minus 5. So then if I simplify that, 7x minus 4x, that would be 3x, and negative 35 and negative 38, or negative 35 and negative 8 would be negative 43. And since that's clearly not going to have a factor of x plus 2 or x minus 5, I'm going to go ahead and multiply these back out, and I would get x squared minus 3x minus 10. And that would be my final answer. Okay, so over here, this one, notice we can't really see the factors, because again, when you get a common denominator, you want to be able to find, make sure that both denominators have all the factors of both things. So before I get a common denominator, I'm going to factor this. So that'd be y, and plus 2, and plus 5. And so you can see that this already has a y plus 5 like that one. So my common denominator is going to be y plus 2 times y plus 5. Y plus 2, oops, y plus 2 times y plus 5. And again, to get this one right, the first fraction is missing a factor of y plus 2. So I got to multiply top and bottom by y plus 2. So that would be 3 times y plus 2. Now notice the second fraction already has both factors. So I don't need to do anything to it. So I just leave it as y over y plus 2 times y plus 5. Then I'm going ahead and multiply this out and add them together. So I'll hop down here for a second. So that'd be 3y plus 2 plus y. And on the bottom, I'll have y plus 2 times y plus 5. So I add those together. I get 4y plus 2 over y plus 2 times y plus 5. Now I could factor the 2 out of that. That would leave me with a 2 times 2y plus 1, which doesn't cancel with anything down there, so I'm not going to bother doing that. So I got to finish this by going 4y plus 2, and then multiply these back out. So that would be y squared plus 7y plus 10. Aren't these fun? Okay, here's a nice one. It's just the common denominator here would just be 4x, wouldn't it? Because 4x has a factor of 2x in it. Because 2 times 2x equals 4x. Of course, that one has already got 4x. So here I'm multiplying top and bottom by 2, so that would be a 6. Add these two together, and I get 11 over 4x. That was a fun one. Okay, here's another one that's, again, pretty straightforward with the factors. The common denominator is going to be x minus 3 times x plus 7 minus x minus 3 times x plus 7. So this one I'm going to have to multiply, the first one I can multiply top and bottom by x plus 7, so that would be 2x plus 14. Hope that's okay, I just did that in my head. And then this one's going to be, I have to multiply top and bottom by x minus 3, so I'll just put x minus 3 in there. And when I do that, I add those two together, well actually subtract them, so 2x minus x, that would be x, and 14 minus a negative 3, that would be positive 17. And since that's clearly not going to factor with anything, cancel with anything down here, I'm going to multiply those back out, and I'll get x squared plus 4x minus 21. Okay, I think I'll pause the video and finish this, and then come back on so you can see my results. Okay, so I finished up the rest of those. There's 44, 45 is right there. And then there's 46 and 47. You see that whole thing there. 48. That's kind of a nice simple one. And then 49. And that's simplifying rational expressions. Lots of fun. All right.